is the co-founder and the Chief Technology Officer at AISF19. He just gave a talk about unleash computer vision at the edge. Could you share some practical applications of computer vision for real-world use cases and tell us a little bit more about who you are in terms of working on this?
Sure. So what we do is enable what we call the inferencing stage of computer vision, so the runtime. Even we use the term forward pass, you'll hear that in it. So that's what we're really focused on edge devices that are either connected to the network or unconnected. So all the inferencing and the processing happens down there. It can send things back to people on the internet, but it doesn't have to. And so if we looked at some of the practical devices, let's just talk about emerging markets in healthcare. So one of the things is if you're out in remote areas, there's not a lot of lab technicians and things like that. So if you have a classification-enabled microscope, so it has our platform running on it, has a model that can say identify malaria and things like that, you can take that out, take your samples, and those samples can be analyzed, and you don't need to connect into the cloud. It's running, it can tell you what that is, and it will actually take the place of a lab technician that wouldn't be available out there anyway, right? So that's one example. There's other examples in smart cities where there is no electricity or something like that, or connectivity in that area. So a lot of times they'll have to put these devices out on batteries and so forth, so it's a low profile performance thing. And it can tell, we have one case in Ireland where it tells whether a person should be there or not during certain times or groups of people. And then this would send a text message off to the park authorities and they'd come and do it, and so forth. That's another example. Another example is counting of livestock and so forth out in the fields and so forth. That's another example that we have of a practical application. So there's all. The big one that everyone talks about is autonomous vehicles. So if you're out there, you're not going to have time to make decisions and so forth, so it's got to be very fast and it's got to be localized. So again, you can't go to the cloud for the inferencing or depend on it. So the LiDAR system will bring in, I see this object, and then the inferencing engine that's doing the computer vision piece will say, well, this is what you're seeing there to the system. And so, and it has to be done at, line speed about 33 frames per second for that to happen. Again, that has to be done on the edge.
Yeah. Thank you for sharing so many good applications. Are there any trade-offs between cloud and the edge-based?
Yeah, and I think that the trade-offs really occur right now between your training and your runtime. Yeah. So you never want to use these devices for runtime because most of them are CPU-based that are out there now. They don't have the GPUs and so forth and the horsepower to really crunch through all the data and the storage of that data. So they're limited in resources, and then power would be another thing we just talked about. So the training should always happen on the cloud-based system or workstations. And this might surprise your audience, but most professional-based model builders use NVIDIA workstations and things like that because the cost of the cloud is very expensive. If you lease it over time, it gets pretty expensive. So if you fix the asset, it gets cheaper over time to do that type of development. But anyway, you get back on track that for training you don't want to do on these lower power edge devices. Now, if you're building like a consumer application or something like that that involves computer vision, you don't want to keep charging your customer to go up to the cloud or force them to have connectivity. So there may be places where you don't have that in a house or something like that. Or for example, let's say you do have electricity and you hook it in, and I want to detect packages when they're left off at my doorstep and things like that, so I can tell somebody to pick them or count to make sure that the right number is left there and things like that. You don't want to charge and send back up. I think GPUs run about $20 an hour. You don't want to do that on that type of application because it will eventually go over the cost and the consumers will buy that. So those are just some of the examples.
Yeah, thank you. My final question is, what is your advice on potential ways to simplify the complexities of building this set of technologies?
Yeah, so the way we've approached it, at least, and then we'll talk about the inferencing, is what we try to do for our end users is we have a standardized API for, say, like object detection, classification, tracking. And then what we do underneath is we have them do one call, and we take care of everything that needs to happen. Formatting the image, the downloading, running of the model, And then if you want to change your inference engine, say they have Google, which has a TPU-based system and so forth, then we abstract that from the end user. Same API, all they have to do is change a little parameter that says use TPU, use GPU, use this. So what we try to do is make sure that they're, and then they don't have to worry about frameworks like TensorFlow, PyTorch, and things like that. So what we've tried to do is, here's my application, it's valuable, I want it to run always, but I may make some changes on what's happening underneath, or I may have a heterogeneous environment that I'm deploying to that have different devices, different accelerators. So the same application can run across all those. And that's how we've kind of simplified it. So, and what our philosophy is, don't get caught up in all the technology battles and things like that. Just build your applications, we'll make it easy for you, and then we'll take care of all the hard part. So,
Thank you. Yeah.
Sure.
Thank you for making it easy for the customers.
Yeah, well,
Yeah.
we enjoy it. We love it.
Yeah, great. Yeah, thank you for participating with us.
Okay, well, thank you for having us. We really enjoyed the conference.